Dante, aka Bucket B.
Lieutenant Conklin here, and today we're going to be talking about the effects a sunburn has on skin cells. So, to begin with, you ever been on a hot sunny day? You're out having fun in the sun, huh? All of a sudden, it's a little messed up, but this isn't our class, so you turn red all over, red everywhere. Everywhere. That's a sunburn. So what a sunburn is a radiation burn by UV rays damaging the DNA of skin cells, typically on the upper layers of the skin. So that's what a sunburn is. Just a basic rundown of that. There are three types of UV radiation. Three types. Right? Three types. You have UVA, UVB, and UVC. UVA and B are very damaging to skin cells. Very damaging. UVC is completely absorbed by the Earth's ozone layer. So you have the Earth, right? It's got this protective little bubble around it. It's called the ozone layer. It absorbs UV radiation, and it completely absorbs all of UVC. So we'll just completely erase that. Let's talk about UVA and B real quick. Ignore that. So UVA, UVA and B, they both penetrate skin if it's unprotected. UVA, photons from UVA interact with skin, damaging proteins, membranes, and DNA. So you've got your skin here, right? UVA comes in and it attacks the proteins and membranes of that skin cell. It's pretty bad. You don't want that. UVB is significantly worse for you because it is directly absorbed in your DNA. So it comes in and it's directly absorbed in the DNA of the cell. And it comes in and it creates mislinks of the DNA. So these are mislinks caused by UVB radiation. And so yeah, not optimal. And so when the skin cell detects these mistakes, it stops replicating DNA. It completely stops it, and it tries to repair this mistake, and this mistake, and this mistake. And it becomes overwhelmed by all these mistakes, and it blows itself up. It self-destructs, destroying this before it can become cancer. Ignore that. So not optimal. So as I said before, or not as I said before, disregard that. So you've got the top layer of the skin, the keratinocytes, I don't know how to say it. Once they find the damaged DNA, they send a signal to the immune response via cell phone. They send a little signal to the immune system for a response. And what the immune system does is the immune system, it requests support from the immune system. And so you've got your blood here, or your skin here. You've got your layers here of skin cells. And so what it does is, you've got blood vessels running through, obviously. These blood vessels leak fluid out of them, filling the spaces between the cells. And this causes that red sensation and the hot feeling of a sunburn. It's from that leaking fluid from blood vessels. And the immune system response typically peaks 24 to 48 hours after you were in the sun. So that's why sometimes when you're out in the sun, you're just a little pink, and then 2 days later, you're blood red everywhere, and you want to die because it hurts really bad. So yeah, and then blisters from sunburns. So in severe cases, you can develop blisters from a sunburn, which is no good. You're all happy, and then you're really not happy because you got these little bumps and painful pus sacs all over your body from getting burned from the sun. So what that is when the entire layer of keratinocytes dies, it lifts. Like it lifts and separates from these bottom layers. And that fluid I talked about before, leaking from the blood vessels, it fills in this layer and it causes a bubble. And it's filled with that liquid. So that's what the that's what a blister is. So no good. You don't really want that. And then when your body begins to heal itself, inflammation subsides. The inflammation from this sunburn, you got your blisters here, it goes down. Eventually, it sucks for a long time, but eventually this does go down, and so the inflammation subsides, all the fluid will begin to leave that area and just disperse back into the body regularly, and your bottom layer of skin continues to produce skin cells, and it pushes up and up and up, and it's repairing and repairing and repairing, and these new skin cells are wired a little differently, so they push up from here, and they kick out the old, and that's why you get peely flakes of dead skin from sunburns, because it's just getting rid of that old skin, that damaged skin. And so that new skin, as I said before, it's a little different. So when the keratinocytes are damaged in the DNA, this is a phone, hold on, that's not a dirty image, that's a cell phone, it's not very good. It's not a dirty image, I promise. They call melanocytes, I'll make them red for effect. They call them, and they're like, hello. They say hello. And what these melanocytes do is they get told to produce more melanin. And when they produce more melanin, that creates a darker skin tone. And so what melanin does is, you got your skin cells here, just kind of wavy around, just hanging out. The melanocytes produce melanin, which covers these cells. This is a wall of skin, like the top. They cover these cells to shield from radiation from the sun. And it's estimated that melanin in a typical human being is the equivalent of SPF 2. SPF 2. My buddy here will go on to explain what SPF is.
Sweet. Thank you. Okay, SPF is short for sun protection factor. Studies have shown that SPF 15 typically covers around 93% of UVB radiation. SPF 30 covers around 97% UVB radiation. And then anywhere from the higher ones like SPF 100 cover around 99% of UVB radiation. The study also shows that there's very minimum factors, so SPF 30 and higher do typically around the same thing. Studies also show that when you apply every 2 hours, SPF 30 does the same exact thing as like higher ones like SPF 100. So it's just, if you're applying it and everything, SPF 30 would be fine. Now for the more cellular research. There was a study used with SPF 55. I'll put that at the top corner here so y'all can remember SPF 55. So MED, for more specifically minimum erythema doses, is basically how much UVB radiation they were allowing on the skin. Unprotected skin, they used, I'll just put UMP means unprotected. They used 1 and 3 MED. And then for skin with SPF 55 applied, they had 55 MED. So as you can tell, they put a lot more radiation when applying the sunscreen. And then for the base, of course, they had unprotected skin with 0 MED, so they can compare. Studies show that 12 cells are typically affected. Cut that off. Typically affected when the UVB radiation contacts with the skin. Actually all 3 of the MEDs, you can see noticeable damage to 4 out of 12 of the cells. 3 MED show that it was pretty significantly damaged. Times this, like I said earlier, the cells can explode or just not able to replicate. With the SPF 55 with 55 MED, show the same results as unprotected skin when 1 MED is applied. So it just shows to you that when SPF is applied, it does really good because you can see noticeably more UVB radiation and it's still the same effect as barely any UVB radiation at all. So that's it.